calculate it based on moles now, what we do here is, you know that 1 mole of copper will give us 1 mole of copper oxide will give us what? 1 mole. 1 mole of copper sulfate. So based on that, the first thing we do here is to convert this very one to moles. To convert it to moles. Converting it to moles, what we get will be 32 divided by 80. We have 0.4 moles. So since 1 mole in every chemical equation, in every balanced chemical equation, there are basic things you will find out from that balanced chemical equation. For example, what we have here, we have magnesium reacting with chlorine to give us magnesium chloride. So from this chemical equation, there are two things we can find out here in regards to what we are going to be solving here. One of the things is the mole relationship between these compounds, magnesium and magnesium chloride. You can see that they have 1 mole and 1 mole. Now the question says 42 grams of magnesium chloride reacts with chlorine. Magnesium reacts with chlorine in excess, which is in excess. To calculate the mass of magnesium chloride produced. So now we are going to be using this chemical equation to solve the calculation, to find the mass. And to find this mass, there are two methods of doing this. One of the ways of doing this is to calculate in moles and come back to mass. I'm going to show you these two methods, but I will start from working with mass to mass relationship. This is talking about the mass of this to mass of this in order to get the required mass we need. So from here, you notice that one of the things we can find here is a mole relationship. We have mole, 1 mole is to what? 1 mole. Another thing we can find out here is the mass of the reactant. The mass of the reactant is what? 24 grams. And the mass of the product, from this balanced equation, you can see that what we have here should be around, it should be 90, either 94, but let me confirm. We have chlorine, so magnesium is 24, chlorine is 35.5 times 2, because it's 2 here, that will give us 71. Okay, 24, 24, we have 5 here, 7, 8, 9, okay, 95, that is what we have. Now if you don't know how to do the calculation, if you don't know how to come about it, I think this will be a very clear hint on how to calculate it. To do this thing, you need to find the relative molecular mass of magnesium, adding it with the relative molecular mass of what? Chlorine. Chlorine here is what? 35.5. Since chlorine is 2 here, 35.5 times 2 will give us what we want. We'll add it up, we'll have 95. So what it simply means that if 24 grams of magnesium combines with chlorine in excess, it will give you 95 grams of magnesium chloride. That is what we have here. So now, since we have succeeded in establishing this, what it also means that now we're going to find out what 42 will be. What 42 will be. Now, if that's the case, 42 grams of magnesium will then give us 95 over 24 multiplied by 42 over 1. So by doing this, what we are likely to have is something 166.3 grams of what? Magnesium chloride. That's approximately 166.3 grams approximately of magnesium chloride. So now we're going to be solving. This is when we are solving from what? Mass to mass, considering the masses. Now, if you are to solve it from the other method, from that angle, the first thing you do here is to convert this very one to what? moles. This mass will be converted to moles. So for us to do that, let's see what we're going to get again. Note our result here, and then we'll use it to, we're going to work in another with another method, which is mole. Since we have 42 grams, now we know that in moles, mole is equal to mass over relative molecular mass or molar mass, as the case may be. So here we have our mass, our given mass is 42. Molar mass of magnesium is what? 24. Since it's 24 divided 24, 42 divided by 24. Let's see what we have. 42 divided by 24, we have to give us 1.75 mole. 1.75 mole of magnesium. So now we have the value 1.75 mole. So now we can still work with that. Since we know that 1 mole of magnesium will give us 1 mole of magnesium chloride, so 1.5 mole will give us 1 over 1 times 1.75. That will give us the same thing. Do you understand? 1 multiply 1.75 will give us the same thing as what? 1.75 moles of what? Magnesium chloride. So now we have the mass. We have been able to know the number of moles of magnesium chloride that will be produced. What we do now is to convert it to mass, because we need the mass. Remember, we need the mass. This is not the final answer, because that is not what we are asked to calculate. So for that reason, we also know that, like as I've already established before, we know that mole is equal to mass over what? Relative molecular mass. Now, for this mole now, to get the mass, what it simply means, mass will be equal to mole times what? Relative molecular mass. Now, the relative molecular mass of magnesium chloride is what? 95 multiplied by 1.75. Let's see what we get. If we multiply through, we have a. So what we have is exactly the same thing. We have 166.3 grams of magnesium chloride. So that is just exactly how to do it. You can see that I've solved the same problem. One problem with what? 2 different methods. That's how calculation can be done in chemistry. In most time, you can start from the mole, especially when we talk about stoichiometry relation, when you're looking at the stoichiometry relationship. Now, from the stoichiometry relationship of this, we're able to find out how we can manipulate those relationships in order to get this. From mass, we started from mass to what? Mole to mole, then we'll get back to this. So the next one we're going to be doing now, we're going to be solving the second question. Say that excess tetraoxosulphate acid reacts with 32 grams of copper oxide. So calculate the mass of copper 2 tetraoxosulphate formed. That will be formed. Now, the first thing we do, anytime you have a question like this, the first thing you need to do is to write a balanced chemical equation of what you are given. The balanced chemical equation of what you are given. If you are not able to get that thing done, that's the beginning of the failure. So now let's look at the balanced chemical equation of that, and it's already given us. We have sulphate to give us copper 2 sulphate plus water. So this is what we have. This is the balanced chemical equation. From this balanced chemical equation, we'll be able to see how the reaction takes place, and we're able to know the masses that is required in this standard environment. Now, for for what we are looking for, based on what we are looking for, say that copper oxide react with excess tetraoxosulphate 6 acid. That means this one might not be, we don't have much to do with this, because we are working with what? The mass of this. This is more like the mass that determines what happens. This is in excess, which means this other, once this one finishes, everything will end there. So in that case now, we have this, and then we're also looking at this. If from the chemical equation, we have 1 mole to give us 1 mole. That is what we have. Now from the same chemical equation, we know that the mass of this copper that is reacting here, now based on the mass of the copper that is reacting, we're going to be looking at the mass of the copper that is reacting. Copper, we know copper to have a relative molecular mass of 64, and oxygen is 16. That is 64 plus 16. We have 80. The mass from this chemical equation, 80 grams. From here, 64 plus 16 will give us 80. Now, in this case here, we have 16 oxygen multiplied by 4. We have 16 oxygen times 4. We have 64 plus sulfur, which is 32, plus 32, and then plus 64 again. What we have for the mass of copper sulfate produced is what? 60 grams. So this is what we have from this chemical equation we have here. From this chemical equation we have here, we've been able to find out the moles relationship and the mass relationship. Now, based on this now, we are going to be finding the mass, what will happen when 32 grams of copper oxide react. We know that 80 grams of copper oxide will give us 160 grams of copper 2 tetraoxosulphate 6 or copper sulfate. Now, what will this 32 give us? 32 grams will then be over 80 times 32. 32 over 1. So multiplying through, we have 160 times 32 divided by 80. So the mass we have here, the mass we have will be, 60 multiplied by 32 divided by 80 will give us 64 grams. 64 grams. So that is what we have. So in that case, the next thing we are going to do now, we've been able to get this thing done. The next thing we are going to do is to find out what we are going to get if we multiply it. If we are to multiply, if we are to be multiplying with, if we are to be working with moles, if we are working with moles now, so if we are working with moles, so what are we going to get if we are working with moles? So to calculate it based on moles now, what we do here is, we know that 1 mole of copper will give us 1 mole of copper oxide will give us what? 1 mole. 1 mole of copper sulfate. So based on that, the first thing we do here is to convert this very one to moles. To convert it to moles. Converting it to moles, what we get will be 32 divided by 80. We have 0.4 moles. So since one mole will give us 1 mole here, it simply means that 0.4 mole of this will also be produced. 0.4 mole of what? Copper sulfate will also be produced. Now in order to calculate the mass, because we are required to get it in mass, in order to calculate it in mass, what we need here is to calculate from what we have done so far. We know that moles is equal to mass over relative molecular mass. From here, this is equivalent to the relative molecular mass of copper sulfate. So to get the mass, we mean mass times mole times relative molecular mass. That means 190 multiplied by 0.4. That will give us exactly what we want. Multiplied by 160, not 190, please. We also have what we have also 0.4 multiplied by 160 will give us 64 grams. You can see that both methods give us the same thing. But one thing is that whenever you're solving problem like this, I always encourage that you use the method that will be fastest. Because me personally, come to solve this, I will use the method that is fastest. Working from gram to grams makes it faster, because sometimes maybe out of tension or whatever, one might tend to forget to convert this mole to what? Mass. Thank you so much for being part of the class. And if you are joining us for the first time, we encourage you to subscribe. And if you have any question, you can also leave your question in the comment section. And this very question you're looking at now will appear in the description of the very video. Thank you so much.